Hello, and today we're going to be talking motors for Hacky Racers, and in particular we're going to talk about three types of motor. Firstly, it will be the e-bike motor that is quite common and readily available. Second is something that didn't actually start life as a motor, I'll explain later. And finally, third is the brushless motors that are commonly used across RC cars, planes, and also used a lot in fighting robots. So let's start with our e-bike motor. So in front of me we've got an e-bike motor. It's pretty common. It runs on 48 volts. It's a brushless motor and it produces, according to the label, 1,800 watts. These retail around £80 and you can get them including a controller and a throttle grip as well. So you can buy a complete kit which works together. And you'll notice here we've got the connector for the Hall effect that plugs straight into the e-bike controller, along with the windings for the brushless motor. Because it's brushless, there's three. I've just used a plug rather than the three ring terminals which get supplied with that. The controllers usually look something like this, quite big, quite weighty, and with a range of connectors. Many of those connectors aren't required for a Hacky Racer. They're to do with cruise control, brake lights, things like that. So really you often just need to put on a connector for the power, a connector in my case so it plugs neatly in to the motor, and then a couple more and off you go. Really the throttle and a positive for the ignition. So out of all those connectors you've only got 3 or 4 that you're really reliant on, and the thing runs off and goes. So this gives quite a neat little package. These are quite weighty. I'm guessing that this is 5 or 6 kilos, so yeah, not inconsiderable. One of the good things about that weight though is it provides good thermal mass. So if you're running for a long time, then there's a lot of mass there to absorb the heat that naturally a motor generates. So yes, nice and easy to package. One of the things with this particular variant is it's got a mounting foot so that it's easy to get good chunky bolts in to hold it, which is important I think, and I'll show you why in a second. You can also face mount. There's a couple of bolt holes there which you can mount this in. Not so sure about that, and when I originally bolted this to my Hacky, I thought I'll save myself some time, I'll use an aluminium plate to bolt it to and bolt that to the Hacky. Well, this is what happened to the aluminium plate. So the torque reaction basically just bent this. This was originally straight, now it's like a banana, so that goes in the bin and gets replaced by a nice steel variant so that it doesn't bend. So yes, I should use thicker aluminium, but I think it's an illustration of how much torque these can produce for a relatively cheap motor, then that's a good example. The second motor I said is not a motor, it's an alternator. This is in the process of being converted, and you can see it's a regular car alternator. I think this was off eBay. It was £10, so £80 versus £10. So a big difference in terms of availability, and you can still run them off these controllers. And you can see around the back at the moment there's lots of wires coming out. These are for the coils, which normally are there for helping to generate electricity, and here is the brushes to the stator. So you have to do some work to get these into a functional motor, and there's lots on YouTube in terms of converting alternators into motors, and you can go from a really simple conversion, which obviously this one's going to be, all the way up to making them fully permanent magnet motors. Again, quite a chunky package. I mean, this is probably weighing in similar to that motor. They produce a little less, I think, wattage. I think these are around 1400 watts rather than the 1800 advertised here, so something to watch out for. They don't have normally the Hall effect sensors. The Hall effect in these motors allow the controller to understand the position of the shaft, so you get better, especially low speed control. But you really can live without that. A lot of the time the Hackies, you're at high speed or full throttle at least, even if you're not moving very far. So these are a good alternative. The other opportunity with these is, with the budgets that you have, is once you add the motor in, the controller in, that takes a chunk of budget. With alternators, £10 a pop. With a controller, you could run 2 of these, so you could have a split rear axle, independently run each of the wheels on the back. So that's really a good opportunity. Obviously you're current limited, so you can't go too far with these, but it does give that cheap and easy opportunity to run a twin motor setup, but probably doesn't fit within budget with these. One thing to note is, when you watch a lot of the YouTubes on converting these motors, then they either have a separate pack of cells to run the windings on the stator, or they skip that completely and run a bench power supply and say, look, I'm giving it 5 volts, 2 amps. That's really not going to work in a mobile application like a Hacky, so you do need to think about how you're going to supply the stator. And one of the ways you can do that is using one of these. This is a step down controller. It's a AliExpress special. It was something like £6-7, and this will take the 48 volts that you're going to run your controller on and give you like 5 volts out. Yet to see how well it works, but at that price then it's not much lost if it goes pop, and it's worth a shot. And that helps simplify the whole power supply arrangements, so you're not running a separate pack of batteries to run this. You've just got one pack of batteries, step down controller, and this is much more efficient than trying to do it through a resistor pack or something. It's just going to burn most of that energy as heat and sap your batteries in the process. So that's motor number 2. That's converting an alternator into a brushless motor, and with a little bit of work and a good soldering iron, you can get these going. Our final example is a brushless motor, commonly used within RC cars and often in fighting robots. And this fella here is another brushless. It's got Hall effect sensors. This is a 63-68, that means its diameter across there is 63 millimeters and 68 is the height. So quite a small package. If you believe that, as advertised, these are 2.5-3 watts, so considerably more than this fellow here. And you say, well, why don't you use these? They're not such a difference in price, maybe even a little bit cheaper than the Hacky. Well, thermals are one thing. You know, these are designed often, especially in the aircraft variants, to have air cooling. You know, you're going through the air, you get air cooling, so you haven't got the thermal mass, you haven't got that heat transfer. Some of the tests that some of the guys have done have shown how that heat really builds up in these motors. So that's one thing to think about. The other is, usually they're coupled with a more exotic speed controller. So these speed controllers here, which are used with the larger brushless, are made for e-bikes, very common in China, electric scooters, hence a lot of the Chinese writing on them, and they're pretty simple in terms of their control mechanism. These things are much more used with things like this. This is a VESC, great controller, lots on the marketplace, but they're not cheap. This is a Foxbox. It's a smaller variant than perhaps one you'd want to run your Hacky with, but these are up in the region of £70–80 for the controller compared to your 20 to 30 for these. So a sizable difference, but using these gives you much more control. You're then able to program the rates of acceleration from the pedal. You're able to play a lot more tunes with it. It is a bit of a black art, and there are good YouTubes on how to program your VESC, but it's not plug and play. These have no real programmability. You plug it in and you get what you get. VESCs, on the other hand, really do allow a lot of tuning, but with tuning comes you've got to put in the time to get the best out of it. And of course this combination here, which is great, is once you've added these together, £150–160, as opposed to the bottom end with your alternator, step-up controller and bike controller, you're probably talking £50. So it's a big difference, and if you've got a restricted BOM, then you're really potentially up against it by using these. But this is, if you can fit it in, is a way to go. Just be prepared to use a bit more electronics. You can also go hybrid, so there's nothing stopping you using the VESCs of the world with the e-bike motors of the world, or even the alternators. And certainly that's one of the things I'll be trying soon, is e-bike motor with a VESC, because my Hacky at the moment, the low speed control is a bit stuttery, so seeing if we can tune out some of that by how the VESC responds to the pedal. So hope you enjoyed that. Really quick run through of 3 motor variants that are quite popular within the Hacky world. All come with the pros and cons, from the simple straightforward package that is the Chinese e-bike, the bit more soldering proficient alternator but cheap and cheerful, get any sort from a scrapyard, up to almost a Rolls-Royce version, which is a brushless and a VESC, thinking about your thermal mass and your tuning.